The given one problem is students of a school decide to plant trees in and around the school to reduce air pollution. It was decided that number of trees that each section of class will plant will be the same as the class in which they are studying. Example, a section of class 1 plant 1 tree. A section of class 2 will plant 2 trees and so on till class 12. There are 3 sections of each class. How many trees will be planted by the students? That is the problem here given. So in that school there are class 1st to 12th class there, and each class students how much their studying class, that much plants they planted. That means first class student plant 1 tree, second class students plant 2 trees, third class student plant 3 trees, and 12th class student plant 12 trees, and each class is 3 sections. That means first class student 1 plant and 3 sections purpose 3 plants total. First class students planted, second class students planted 2 plants, but in that 3 sections there, that purpose 2 2 2, that means total 6 plants they planted. Same that like 12th class students to observed means they will be plant 12 plants, but 3 sections there, so 12 12 12, that means 12 3s are 36 plants they planted. So sum of these all numbers is nothing but total number of plants they planted. Okay, now so number of classes in that school, that is 12 given, that is nothing but class 1st to class 12. So section of each class, that will be 3 sections given. So now planted plants by first class students is equal to 1 into 3, that equal to 3. Plants planted by second class students, that is 2 into 3 is equal to 6. Now the third class students planted plants, that is 3 into 3, that equal to 9. So fourth class students planted plants 4 into 3, that equal to 12, and so on. There are up to 12 classes there. So 12th class students planted plants, that is nothing but 12 into 3 is equal to 36. Now this information will be writing as series. So the series is 3, 6, 9, 12 and up to so on 36. Now here this series is in arithmetic progression or not, first we observing. So the first term a1 is equal to a equal to 9 3, and the second term a2 equal to 6, third term a3 equal to 9, and the last term L is equal to, that is nothing but there are 12 classes there, that is A12 equal to 36, that means n value is 12. Now we observing the common difference D is A2 minus A1, that equal to 6 minus 3 is 3, and A3 minus A2 calculating, that is 9 minus 6, that is also 3 came. Now if A4 minus A3 doing, that is 12 minus 9 is also 3 only. So here the common difference is same. So the information is in AP, arithmetic progression. So now here up to class 12 how many plants are planted, that is nothing but sum of the 12 terms. So SN is equal to, by using that principle, here we know the first term and the last term. So we use Sn is equal to n by 2 into a plus l, that principle using. So that is nothing but S12 is equal to 12 by 2 into a equal to 3 and l equal to 36. So 12 by 2 is equal to 6 and 3 into 36, 3 plus 36 is equal to 39. So 6 into 39, 6 into 39, 6 9 ja 54 and 6 3 ja 18, 18 plus 5 that equal to 23. So total planted plants 234. So total students planted up to class 12 234 plants. Given problem, a sum of rupees 700 is to be used to given 7 cash prizes to students of a school for their overall academic performance. If each prize is 20 rupees less than its preceding prize, find the value of the prizes. That is the information given. So here the sum of 700 rupees to be given. So distributed amount that is nothing but Sn, that equal to 700 rupees given. Now here 7 cash prizes there, so number of prizes that is nothing but n equal to 7. So here Sn is nothing but S7 and here given each price is 20 rupees less than its preceding price. So each price cost preceding one to rupees 20 less. So that means it is nothing but we have to take the common difference is equal to minus 20. Common difference D equal to minus 20. Why? Because less given. So now here n S7 value and D value we know and the first price value we don't know. So let the first price value, that is nothing but A1 is equal to A as taking rupees X. Now sum of the n terms Sn is equal to, we know, n by 2 into 2a plus n minus 1 into d. So here sum of 7 prizes given. So S7 is equal to n by 2. So n value is 7 by 2 into 2 into a value is x plus n minus 1, 7 minus 1 into d value is minus 20 is equal to total prices value is 700 rupees given. Now this multiplication 7 by 2 transfers to RHS, that is its reciprocal to we multiply, that is equal to 700 into 2 by 7. So 7 ones 7 hundreds. So 100 into 2 is nothing but 200. Now 2 is multiplying with x, we get 2x plus 6 minus 1 2 into minus 20. 2 into minus 20 is nothing but minus 120. So 2x minus 120 equal to 200. Now this minus 120 LHS1 transfers to RHS, we add with 200. So 200 plus 120, 200 plus 120 is equal to 320. Now these multiplication to transfers to RHS, we want to divide 320 by 2. 320 by 2 is equal to 160. So the first cash price, so the amount of first cash price equal to 160 rupees. Now asked find each price value, that is, so we finding, so values of each price. So first one, that is nothing but x equal to rupees 160. Now the second price is first to 20 rupees less, that is 160 minus 20, that equal to 140 rupees. Now the third price cost 140 minus 20, that is equal to 120 rupees. Now the fourth price cost, that is 120 minus 20, that equal to 100 rupees. Now the fifth price cost, that is 100 minus 20, that equal to 80 rupees. Now the sixth price cost, that is 80 minus 20, that equal to 60 rupees. Next, seventh price cost, that is 60 minus 20, that equal to 40 rupees. So the seven prices cost is 160 rupees, 140 rupees, 120 rupees, 100 rupees, 80 rupees, 60 rupees and 40 rupees. The given problem, find the sum of first 40 positive integers divisible by 6. So up to 40 positive integers divisible by 6, sum is how much? So 6 to divisible numbers, first 41 taking. So the numbers divisible by 6 to first 40 numbers are nothing but we can write 6 ones, 6 twos, that are nothing but multiples. So 6 threes and so on, 6 40s, that is only the 40th number. So 6 ones is nothing but 6, 6 twos 12, 6 threes 18, up to so on to 40. Now in that series, the first term a1 is equal to a equal to 6 and the second term a2 equal to 18 and the nth term an is equal to 240 and the number of terms given n is equal to 40. That means it is an is nothing but a40. So this a40 is the last term. So L equal to 240. Now here number of terms n equal to 240 given. So now the sum of first 40 integers asked divisible by 6. So Sn is equal to, the principle is n by 2 into a plus l. First term last term given means, so here n value is 40, S40 equal to 40 by 2 into a value is 6 and L value is 240. So 40 by 2 is nothing but 20 into 240 plus 6 equal to 246. So 20 into 246, that is nothing but 4920. So the sum of first 40 positive integers divisible by 6 are 4920. Find the sum of all 3-digit numbers that are divisible by 4. that is the problem given. So the 3-digit numbers are starting from 100, 101, 102 up to so on 998, 999. Now the first number 100 observed means we know 425 is 100. So 100 will become in 4 table. So that means it will be divisible. So the last number which is divisible, that one observing. So 999 is dividing with 4. So 4 ones 4. So 4 twos we taking. 4 twos 8. 9 minus 8 equal to 1. That is 19. 4 fours 16. So 39. So 4 nines 36. That means 3 remainder. So now 999 to 3 subtract, we get 996. So the largest 3-digit number divisible by 4 is 996. So 3-digit numbers divisible by 4 are first one 100, next one 104 and the next one 108, 4 adding means, and the last one is 996. The last one is 996. Now here the first term a1 is equal to a equal to 100 and the second term a2 equal to 104 and the nth term an is equal to 996 and here n value we have to find. So now the common difference d is equal to a2 minus a1, that equal to 104 minus 100 is equal to 4. Now that nth term general form an equal to a plus n minus 1 into d2 substitute means how many terms there, that one we will find. So an is equal to a plus n minus 1 into d, that is 996 given. A value is 100 plus n minus 1 into d equal to 4 equal to 996. Now this plus 100 transfers to RHS, that is minus 100. So n minus 1 into 4 is equal to 996 minus 100. 996 minus 100 is equal to 896. So n minus 1 into 4 is equal to 896. Now this multiplication 4 transfers to that side, that is division. So n minus 1 is equal to 896 by 4, that is equal to, so 224. Now this n minus 1 equal to 224. Now this minus 1 transfers to that side, that is plus 1. So n equal to 224 plus 1, that equal to 225. So now 100 to 996 225 terms there. So now here the first term and the last term we know. So sum of the numbers SN is equal to, we can apply n by 2 into a plus l principle. So here n value is 225. So S 225 equal to 225 by 2 into a value is, that is 100 and L value is 996. So that equal to 225 by 2 into 100 into 100 plus 996 is 1096. So 225 into 1096 by 2 is equal to 1,23,300. So sum of the 3-digit numbers that are divisible by 4 are 1,23,300 there. Given problem Find the sum of all 3-digit numbers which are divisible by 3 and not divisible by 6. So here 3-digit numbers to 3 to divisible but not 6 to divisible. That one numbers sum is how much? That is the question asked. So first 3-digit numbers observing. So 3-digit numbers are 100, 101, 102 up to so on 999 there. Now in that 3 to which numbers are divisible observing. So 100 is dividing with 3. So 3 3s 9, that means 10. So 3 3s 9. So the remainder is 1. Now the largest number 999 is dividing with 3. So 3 3s 9. The remainder is 0. So the next digit 9 taking. So 3 3s 9. The remainder is 0. The next number 9 taken. 3 3s 9. So the 999 is dividing with 3. Okay. So now the largest number 999 is divided with 3. Now the smallest number 3-digit one dividing with 3 coming purpose 100 plus 3 minus 1 doing. So 3 minus 1 equal to 2. 100 plus 2 is equal to 102. So the smallest number divisible by 3 is 102 and the largest one is 999. So the 3-digit numbers divisible by 3 are first one 102, the next one 3 to divisible is nothing but 3 multiple. So 3 adding 102, 105, next 108, next 1111 up to so on 996 and 999. Now our to asked in that numbers are divisible with 3 but not divisible with 6 asked. So now if 102 checking with 6 to divisible or not. So now once checking 102 is divisible with 6 or not. So 6 once 6, that means remainder 4, 10 minus 6, now 42, 6 7s 42. So that is 102 is coming in 6 table but 105 is not comes in 6 table. Next 108 is comes in 6 table, 6 18s. So 1111 is not coming. So the last number 999 observe means it is also not coming 6 table. So now the 3-digit numbers divisible by 3 but not divisible by 6 are first one is 105 and the next one is 111 and so on 999. So now here from that the first term a1 is equal to a equal to 105 and the next term a2 equal to 111 and the nth term an is equal to 999. So sum of these numbers finding purpose we have to need the common difference d is equal to a2 minus a1 that equal to 111 minus 105 that is equal to 6. Now n value we have to find by the general form of arithmetic progression an is equal to a plus n minus 1 into d, that principle to substituting. So that value is 999. A value is 105 plus n minus 1 into d value is 6 that equal to 999 plus 105 transfers to RHS that is minus 105. 999 minus 105 is equal to 894. So n minus 1 into 6 is equal to 894. Now this multiplication 6 transfers to RHS, that is division. So n minus 1 is equal to 894 by 6. So 6 to divisible, 6 ones 6, so 29. So 6 fours 24, 59. So 149. So n minus 1 is equal to 149. So this minus 1 transfers to RHS, that is plus 1. So n equal to 149 plus 1, that equal to 150. So total 150 terms there. So now the sum of n terms Sn is equal to, now here we know the first term and the last term. So we using the principle n by 2 into a plus l. So here the number of terms are 150 there. So yes, 150 is equal to n by 2. So 150 by 2 into a value is 105 and l value is 999. 150 by 2 is nothing but 75. 105 plus 995 is equal to 1000. So 14, 10, 1104. Now 75 multiplying with 1104 into 75. So 7 5s 20, 11 5s 55, 7 4s 28, 7 11 7s 77, 0 0 8, 5 plus 2 7 plus 1 8 and 7 plus 5 12 and 8. So sum of these 150 terms is 82,800. That means sum of the 3-digit numbers which are divisible by 3 but not divisible by 6 are 82,800 there. The given problem, find the sum of all integers between 1 to 50 which are not divisible by 3. So here 1 to 50 which numbers are divisible by 3, first checking. So numbers between 1 to 50 divisible by 3 are starting from 3, 6, 9 up to so on. The last number is 48. 3 16s 48. So 48 up to divisible. But here our to ask not divisible with 3. So numbers between 1 to 50 not divisible by 3 are, now the remaining numbers we taking 1, 2, 4, 5, 7, 8, 10 up to so on 49, 50. Now these numbers we splitting as 1, 4, next 7, next 10 and so on. Last one is 49 and 2, 5, 8 up to so on. The last one is 50. That model. Now we splitting. Now here the first series, if we observed in that first series, the first series 1, 4, 7, 10 so on 49. The first term a1 is equal to a equal to 1 and the second term a2 equal to 4 and the nth term an equal to 49. So now the common difference d is equal to a2 minus a1, that equal to 4 minus 1 equal to 3. If a3 minus a2 do, we also get 3. That means here common difference 3, same coming purpose we taken these model series. Now these numbers sum how much find, that means first how many numbers there, that one we want to find. By the general formula an is equal to a plus n minus 1 into d, that equal to 49. Here a equal to 1 plus n minus 1 into d is equal to 3, that equal to 49. Now plus 1 transfers to that side, minus 1. So n minus 1 into 3 equal to 49 minus 1, that equal to 48. So n minus 1 into 3 equal to 48. So n minus 1 equal to multiplication 3 transfers to that side, that is division, 48 by 3, that equal to 17, that is 16. Now n minus 1 equal to 16, then n equal to minus 1 transfers to that side, plus 1. So 16 plus 1 equal to 17. So total 17 terms there. Now these 17 terms sum finding, we know the first term, last term. So Sn equal to n by 2 into a plus l, that principle we using. Now sum of the 17 terms, S17 is equal to 17 by 2 into a equal to 1 and L is 49. So 17 plus 17 by 2 into 1 plus 49. 1 plus 49 is 50. So 17 by 2 into 50. So 50 by 2 is equal to 25. So 1725 is 425. So the first series sum is 425 we get. Now we do the second series sum, how much find. So the second series is 2, 5, 8 up to so on 50. Now here the first term a1 is equal to a equal to 2, second term a2 equal to 5 and the an term is equal to 50. Now here we find the common difference d is equal to a2 minus a1, that equal to 5 minus 2 equal to 3. Now the next two terms subtraction also we done, 8 minus 5 equal to 3. So same common difference coming. So now here it forms arithmetic progression. Now here the nth term an is equal to a plus n minus 1 into d, that is equal to 50 given. Now the first term is 2 plus n minus 1 into d value is 3 equal to 50. Now plus 2 transfers to RHS, that is minus 2. 50 minus 2. 50 minus 2 is equal to 48. So n minus 3, n minus 1 into 3 equal to 48. Now multiplication 3 transfers to RHS, that is division. So 48 by 3. 48 by 3 is nothing but 16. So n minus 1 equal to 16. Now minus 1 transfers to RHS, that is plus 1. 16 plus 1 equal to 17. So here 2, 5, 8 up to 50, 17 terms there. Now here number of terms 17 we know. So now the sum of the 17 terms finding. So here first term, last term we know. So now we using the sum of the n terms, Sn is equal to n by 2 into a plus l principle. So S17 is equal to 17 by 2 into a equal to 2 and l equal to 50. So 2 plus 50 is 52. So 52 by 2, that is nothing but 26. Now 17 into 26 is nothing but 142. So So it is 442, not 142. So 442. Now we have to find that sum of all integers between 1 to 50 that are not divisible by 3. So sum of all integers between 1 to 50 not divisible by 3 is equal to 425 plus 442, that is equal to 867. So the answer is 867.